Imagine a continent unlike any other on Earth, a place where the familiar rules of our world seem to bend, maybe even break entirely. It's this vast, icy, enigmatic realm, just shrouded in mystery, holding secrets that, well, they've captivated scientists, explorers, thinkers for centuries.
Absolutely.
This, you, our listener, know as Antarctica.
It truly is a continent of magnificent extremes. Nature really paints with colors and forms there that we just rarely encounter anywhere else.
Right.
And the phenomena often defy our conventional understanding of well, how our planet works.
Absolutely. And today, we're inviting you on a journey, really, to question what truly makes this frozen frontier so profoundly captivating.
Yeah.
Is it, the sheer scale of its untouched natural wonders, or the ancient whispers of history hidden beneath kilometers of ice?
Or maybe those theories.
Or those truly tantalizing theories that just push the very boundaries of our imagination?
Right. Our mission for this deep dive is to journey through a carefully curated stack of sources, and it's packed, really, with fascinating research and compelling stories to uncover insights into Antarctica's most profound enigmas. We want to encourage you to reflect deeply. Let curiosity be your compass.
Yeah, dig in.
And really engage with the surprising facts and the compelling why
Yeah.
behind what makes this continent such a fascinating subject.
We're not just going to scratch the surface here. We are truly diving deep. We'll explore everything from, well, the mind-bending spectacle of bleeding glaciers and the eerie, unheard symphony of singing ice to hidden subglacial worlds, ancient secrets preserved in the ice,
And the climate impact.
and the profound, undeniable impact Antarctica has on our global climate. Prepare to have your perceptions, well, chilled, challenged, and definitely thrilled. #tag IRAT. Antarctica's stark natural wonders. Okay, let's unpack this. Let's start with one of the most visually arresting and maybe unsettling phenomena on the entire continent. Imagine yourself in the McMurdo Dry Valleys. It's a region so desolate it feels almost otherworldly.
It really does.
And there, starkly contrasting with all the white and gray from beneath the ancient Taylor Glacier, flows this vivid, deep crimson stream.
Yeah.
It looks like the ice itself is weeping blood. It's this striking sight known as blood falls.
It is striking.
Yeah.
Like something out of science fiction, as you say.
Yeah.
But it's very real.
And it's been flowing for a long, long time.
The truly intriguing aspect of blood falls is the natural process behind such a dramatic sight. It's not, as you might guess, actual blood.
Right, okay.
Instead, what we're witnessing is the outflow of extremely iron-rich water.
Iron rich.
Yes, water that's been trapped beneath the Taylor Glacier for, get this, potentially millions of years.
Millions.
In a vast anoxic, meaning no oxygen subglacial reservoir.
Okay.
This ancient brine, isolated from the atmosphere from sunlight, is also incredibly salty. Super salty.
So trapped water, iron, salt.
Exactly. And when this trapped water finally seeps out, maybe finds a fissure, and makes contact with the air, the dissolved iron within it rapidly oxidizes.
Okay, like rust.
Precisely. Think of it like a massive, extremely slow-motion rusting process. That's what produces that distinct, vivid, blood-red hue.
A giant rust stain coming out of a glacier.
It's a powerful visual testament to some really fascinating subterranean geochemistry.
That makes the visual even more incredible, knowing it's geological. But here's where it gets truly captivating for me. How does this ancient brine, this isolated subglacial ecosystem, how does it manage to sustain itself for literally eons?
Yeah.
We know it's been persistently flowing since its discovery back in 1911. So what does that astonishing persistence suggest about the sheer resilience of chemical and maybe even biological systems in environments we once just assumed were completely lifeless? It really challenges our fundamental understanding, doesn't it?
It absolutely does. The persistence of blood falls is, well, it's nothing short of remarkable. Studies have revealed a truly unique microbial ecosystem thriving within this brine.
Life down there.
Yes, life. Adapted to extreme cold, complete darkness, and a complete lack of oxygen.
Wow. How do they even survive?
These organisms have evolved to use sulfate and iron compounds for metabolism. They're essentially breathing sulfur and eating rust, you could say.
Not sunlight, but chemicals.
Exactly. It's a process called chemosynthesis rather than photosynthesis. The implications of this are just immense. It fundamentally broadens our definition of habitable on Earth.
Right. It shows life can find these ingenious ways to survive in deep isolation.
Precisely. And zooming out, the global implications, they're profound. Could similar processes be happening elsewhere, locked away beneath other glaciers on Earth? sustaining unique microbial ecosystems.
That's a big question.
And if so, this discovery profoundly reshapes our understanding of where life might exist, especially, on icy moons in our solar system, like Europa or Enceladus.
Where they think there are subglacial oceans.
Exactly. Oceans believed to be present, just waiting for discovery. So this Crimson Cascade is more than just a geological anomaly. It's a living testament to life's profound resilience, even in deep isolation. It broadens our definition of habitable on Earth and potentially way beyond.
From the striking sight of bleeding ice, let's shift our focus. Let's talk about the sounds, or maybe the unheard sounds of this continent, often called silent.
Ah, yes. The singing ice.
Imagine the vast Ross Ice Shelf. This expanse of floating ice, it's huge, like the size of France.
Unbelievable scale.
Stretching hundreds of kilometers, vibrating with this eerie, low-frequency hum. It's often called singing ice, a natural symphony playing out in infrasound.
You're right. It's a symphony that's mostly inaudible to us, to human ears. But it is undeniably there.
So what causes it?
These subtle vibrations are caused by winds sweeping across uneven snow surfaces, particularly over things called snow dunes or sastrugi.
Sastrugi.
Yeah, they're like hard ridges or grooves sculpted into the snow by the wind.
Okay.
The physics behind it involves generating infrasound, those sound waves, with frequencies below what we can hear.
Right, below human hearing.
As air currents interact with this irregular topography of the ice, they create turbulent eddies. And these resonate through the vast, thick ice shelf, causing it to vibrate like a colossal frozen tuning fork.
A giant tuning fork. Wow.
While we can't hear it directly, these infrasonic hums can be picked up with highly specialized seismographs.
And instruments can hear it.
Yes, and then they can be amplified or sped up in processing so we can perceive them. It's a really powerful demonstration of energy transfer between the atmosphere and the cryosphere, the frozen parts of the planet.
So it's like this giant frozen instrument just resonating with the wind itself. What do these unheard melodies tell us about the intricate interaction between Antarctica's atmosphere and its frozen landscapes? Are they just curiosities, or is there deeper meaning?
Well, they're more than just curiosities. These subtle interactions are actually crucial for understanding energy transfer and atmospheric dynamics in polar regions.
How so?
The frequency and intensity of these hums can reveal information about wind speed, about temperature inversions in the atmosphere, even about the internal structure and stability of the ice shelf itself.
So it's like a natural monitoring system.
In a way, yes. A natural, continuous monitoring system. And putting this into context, these phenomena aren't just isolated things happening in Antarctica. They speak to larger planetary systems.
Meaning?
Well, prompts us to consider if other ice-covered regions, maybe even on distant planets like Mars with its polar ice caps,
Right.
or icy moons with dynamic atmospheres, might be producing similar unheard music. Music just waiting for the right tools to detect them.
So the silent continent isn't really silent.
Not at all. It actually hums this subtle infrasonic tune, revealing critical, often invisible, energy transfers between its atmosphere and ice.
Yeah.
It's a kind of global symphony we're only just beginning to decode.
Our journey takes us deeper now, literally, beneath Antarctica's surface, to reveal an astonishing fact: a hidden world of over 400 subglacial lakes.
400?
Yes. Some of these have been sealed off from the outside world for millions of years, just dotting the entire continent beneath that colossal ice sheet.
This truly is an extraordinary discovery. It fundamentally reshapes our understanding of Antarctica. To grasp the scale, let's maybe focus on Lake Vostok.
Okay. The famous one.
It's one of the largest of these hidden bodies of water. And it sits beneath nearly 4 kilometers of solid ice.
4 kilometers? The pressure must be immense.
Imagine the immense pressure, the complete darkness, the perpetual cold that defines this unique environment.
It's hard to even picture.
Now, contrast that with Deep Lake. It's a fascinating anomaly. This one's in the Vestfold Hills. Deep Lake isn't subglacial, it's on the surface.
Okay.
But its hypersaline waters remain liquid at temperatures far below freezing. We're talking as low as minus 20 degrees Celsius.
Liquid water at minus 20 C. Salt.
Extremely high salt content. So this brings up a vital point. What unique chemical properties allow Deep Lake to resist freezing under such extreme conditions? And what does this tell us about the chemistry of other frozen water bodies, maybe even those subglacial ones?
Exactly. And the implications for life. They're truly mind-boggling. What kind of unique environments might exist in these isolated subglacial waters like Vostok?
Could unique microbes, adapted to extreme darkness, immense pressure, intense cold, could they thrive there?
Imagine the scientific implications of finding life in those conditions. How might that fundamentally reshape our understanding of biology? Not just on Earth, but...
Out there in the cosmos.
Yes.
What might the microbial inhabitants of Deep Lake or Lake Vostok reveal about survival, about evolution in extreme environment?
It really pushes the boundaries, doesn't it, of our definition of habitability.
Absolutely. The conditions in these subglacial lakes are analogous in some ways to what we might find on icy moons like Europa or Enceladus.
So they're prime targets for astrobiology research.
Definitely. Scientists speculate that life, if it's present, would likely be chemotrophic.
Meaning it gets energy from chemicals, not light.
Right. Deriving energy from chemical reactions, maybe feeding on methane or sulfur compounds or iron, like blood Foles microbes.
Finding life like that would be revolutionary.
It would revolutionize our understanding of biology and planetary habitability.
Yeah.
But, and this is crucial, it also brings up immense scientific challenges and ethical dilemmas.
Like, how do you even get there?
Exactly. Think about the incredible technical hurdles of drilling through kilometers of ice to reach these pristine ecosystems. It's a massive undertaking.
And contamination.
Precisely. What extreme precautions would scientists need to take to avoid contaminating these unique environments with microbes from the surface? Preserving their untouched state is paramount.
For accurate science and just out of respect.
Absolutely. Respecting what could be an entirely unique evolutionary lineage. Finding life here would redefine our understanding of life's resilience and adaptability. It's a huge responsibility. #Chat2, landscapes beyond imagination.
From these hidden liquid worlds beneath the ice, maybe teeming with undiscovered life, let's surface. Let's confront a landscape on Antarctica that defies everything you think you know about this frozen continent.
Okay, where are we headed?
I'm talking about the McMurdo Dry Valleys. These are a series of vast, snow-free valleys that form one of the driest places on Earth.
Snow-free? In Antarctica?
Yes. Yet they're remarkably surrounded by a sea of ice. It's a geographical paradox. A desert in a polar wonderland.
That is strange. The truly intriguing aspect here is understanding why. Why this region, despite its polar location, its proximity to massive ice sheets. Why does it receive almost no precipitation?
Right. What's
And key lies with something called katabatic winds.
Katabatic winds?
These are incredibly strong, cold, and dense air currents. They originate high up on the polar plateau.
Okay.
And they accumulate tremendous speed and density as they plummet thousands of meters down into the valleys.
Like an invisible avalanche of air.
Sort of, yes. And as these dense air currents descend, they get compressed by the increasing atmospheric pressure down below.
Ah, compression heats things up.
Exactly. This compression warms the air significantly. You know, like how a bicycle pump gets hot when you use it.
Yeah.
And that warmth literally sucks every last bit of moisture out of the air. It creates this relentless arid wind that evaporates any snow or ice before it can accumulate.
So it actively dries the landscape.
It leaves the valleys bone dry. A true atmospheric vacuum, essentially desiccating the landscape.
So it's not just a lack of snow, it's an active process stripping moisture away. And this desert-like environment, it's often compared to Mars.
It is, yeah.
What makes it so similar? And how does that make it such an invaluable natural laboratory, a testing ground for studying extraterrestrial life or technologies for space missions?
The similarities to Mars are quite uncanny.
Yeah.
You've got extreme dryness and absence of macroscopic life, extensive permafrost, high UV radiation,
Okay.
even the presence of certain salt formations and minerals that we see on Mars. This makes the McMurdo Dry Valleys an invaluable natural laboratory.
So scientists test Mars rovers there.
Exactly. They test rovers, drills, life detection instruments, even human survival strategies for future Martian missions. It's the closest analog we have on Earth for many Martian surface conditions.
That's fascinating, and connecting this to the bigger picture.
Well, these valleys also act as incredible climate archives.
Climate archives, how?
Their extremely low humidity and stark terrain perfectly preserve ancient soils, rocks even. Get this, mummified seals that wandered in and died centuries ago.
Wow. Mummified seal.
Yes, they offer invaluable clues to Antarctica's climatic past, going back millions of years.
So what could studying these incredibly well-preserved archives teach us about the broader impacts of global warming today, for instance?
A great deal, especially in polar regions where subtle changes are often magnified. They hold a remarkably clear, frozen record of Earth's paleoclimate. It helps us understand past climate shifts and potentially predict future ones.
Now let's consider a true anomaly, something that utterly contradicts our mental image of Antarctica: geological activity. And not just any activity.
You must mean Erebus.
Exactly. We're heading to Mount Erebus, Antarctica's most active volcano. It hosts a rare, persistent lava lake, glowing with molten rock simmering in its crater since at least 1972.
Right in the middle of all that ice and snow.
All surrounded by ice and snow. It's an image that just doesn't compute with our usual idea of Antarctica as this frigid, static land.
The science behind Erebus's persistence is truly remarkable. How such intense heat can endure one of the coldest places on Earth. It's a fascinating geological puzzle.
So what's the answer? How does it stay molten?
Mount Erebus is part of a complex rift zone where the Earth's crust is slowly pulling apart.
Okay, tectonic activity.
Right. This tectonic activity creates pathways for magma, that superheated molten rock, to rise from deep within the Earth's mantle to the surface.
So there's a constant supply of heat from below.
Exactly. The continuous flow of fresh hot magma from below constantly replenishes and stirs the lava lake, maintaining its molten state despite the frigid ambient temperatures. It's this powerful, dynamic interplay between Earth's inner heat and its frozen exterior.
A potent reminder of the continent's deeper, fiery nature. But it gets even stranger, and maybe more valuable. Intriguingly, Mount Erebus is known to emit tiny gold crystals in its volcanic gases.
Gold. Seriously?
Actual gold, tiny particles, but still. What processes deep within the Earth could produce such a phenomenon? And what might these trace elements tell us about the continent's deeper geological history? It's literally spitting out treasure into the polar air.
It's incredible, isn't it? The emission of gold and volcanic gases suggests that these deep geological processes are tapping into mineral-rich zones within the Earth's crust and mantle.
Okay.
It possibly involves hydrothermal systems at great depth that concentrate precious metals like gold.
And what can we learn from that?
The trace elements from these emissions, along with other gases like carbon dioxide and sulfur, they act like geochemical fingerprints. By analyzing them, scientists gain invaluable clues about the composition and evolution of Antarctica's continental plate over millions of years, and the dynamics of the mantle plumes beneath it.
So it's a window into the deep Earth.
Precisely. But this brings up another vital point. We must also consider how eruptions, or geothermal heat from Mount Erebus, or maybe other hidden subglacial volcanoes we don't even know about yet.
Right, there could be others under the ice.
How might they influence Antarctica's immense ice stability?
Melting from below.
Exactly.
Mm-hmm.
If significant geothermal activity contributes to ice melting from below, what would be the global implications for sea levels? The sheer volume of ice in Antarctica means even subtle geothermal activity could have widespread, long-term effects. It could potentially accelerate ice loss from the underside of glaciers. It's another piece in the complex climate puzzle. #tag33. Echoes of human endeavor and enigma.
Moving from the natural wonders and these profound geological forces, let's turn to the human story. Antarctica's history is, perhaps surprisingly, littered with moments of extreme endeavor and, tragically, loss.
It is a very harsh environment for humans.
And its unrelenting cold plays this unique role, preserving human endeavors and, sadly, human tragedies. Hundreds of explorers, maybe from early 19th century shipwrecks right up to more modern accidents, are believed to remain entombed in the ice and frozen seas.
Indeed. You take the 1819 wreck of the Spanish ship San Telmo, for instance.
Okay.
It was last seen near Cape Horn before just disappearing. Later, debris clearly from that ship washed up on Livingston Island in the South Shetlands,
Suggesting the crew might have reached Antarctica.
strongly hinting at a lost crew who perhaps reached land but never returned. And the reason Antarctica preserves bodies and artifacts so effectively, it's the extreme sub-zero temperatures and the incredibly low microbial activity.
Right, decomposition basically starts.
Exactly. These conditions virtually halt decomposition, effectively mummifying organic matter and freezing everything in time, almost perfectly preserved for centuries.
It's a chilling thought, isn't it? Almost reverent. What stories might these exceptionally preserved remains, if they were ever recovered, tell us?
They could potentially rewrite history.
You mention a mysterious Chilean woman from the early 1800s, her identity unknown, preserved in the ice. How might her presence challenge our understanding, who ventured to this remote frontier much earlier than we commonly thought?
Such discoveries could profoundly reshape chapters of early polar exploration. The presence of a woman, for instance, in the early 1800s, that would challenge the prevailing narratives which mostly focus on male-dominated expeditions later in the century.
Right, changes the picture.
It might reveal uncharted voyages, perhaps unexpected trade routes, or even previously unknown human connections to this continent. But And this is a crucial consideration.
The ethics.
Exactly. We have to reflect on the complex ethical dilemmas surrounding disturbing such sites. Should we leave these frozen graves untouched, respecting them as memorials? Or is there a compelling historical and scientific imperative to uncover their secrets? It means balancing reverence with the pursuit of knowledge. It's a very delicate balance between discovery and dignity.
Beyond the physical toll, the psychological impact of Antarctica's isolation. That's another profound enigma.
Oh, absolutely.
Explorers, even legendary figures like Ernest Shackleton, reported sensing an unseen, non-physical third man during moments of extreme hardship and despair. It's known as the third man factor.
The science behind this phenomenon is truly intriguing. What could cause such vivid hallucinations, especially in the endless daylight or perpetual darkness of the polar seasons?
What's the leading theory?
The prevailing theory suggests that the human brain, when it's under severe stress, extreme isolation, profound exhaustion, and sensory deprivation.
All the things you'd experience there.
Exactly. It can sometimes conjure phantom companions. It's believed to be an involuntary coping mechanism, a deep psychological defense to combat intense loneliness, fear, and despair in life-threatening situations.
The brain trying to protect itself.
Possibly. Seeking to protect itself, it might create a sense of presence to offer comfort or guidance, even if it's not real.
That truly makes sense, like a primal need for companionship manifesting. But what does this suggest about human psychology in extreme conditions? Given that this third man factor appears in survival stories worldwide, right? Not just Antarctica.
That's a key point. It's a recurring appearance in diverse survival scenarios. You hear it from mountaineers trapped on high peaks. Sailors lost at sea suggests a profound, universal human psychological response to extreme duress.
It's fundamental to how we cope.
It seems so. The interplay of physical and mental stress, intense isolation, prolonged cold, sensory deprivation. It seems to amplify these experiences. It reveals the extraordinary lengths the human mind will go to maintain a sense of sanity and hope under the most unimaginable pressure.
It's fascinating.
One crucial consideration, though, while it's largely understood as a psychological coping mechanism, could such phenomena, for some individuals, also tap into cultural or spiritual dimensions?
Or is it purely neurological?
Or is it purely neurological responses to extreme duress? That's harder to say definitively for every case. Regardless, the human mind's capacity to create its own reality and companions under pressure is undeniable and deeply revealing about us.
Our journey into human endeavors in Antarctica now takes a more mysterious and some would say unsettling turn into the shadow of secrecy.
Euswabia.
We're talking about the enigmatic 1938 Nazi Germany expedition. They went to claim a vast section of the continent, which they named New Swabia. Ostensibly, the reason given was for whaling.
The truly intriguing aspect here is how such an expedition, despite its stated purpose whaling rights, secure fat supplies became shrouded in such deep secrecy.
Right. Why all the mystery?
Its true motives, whether purely scientific or strategically territorial, or maybe something far more clandestine, quickly sparked rampant speculation.
Hidden bases,
secret weapons programs, even occult pursuits. We know the Third Reich had its esoteric interests and grand ambitions.
So the secrecy fueled the fire.
Absolutely. The lack of transparent records from that period, combined with the extreme isolation of Antarctica, it created fertile ground for countless conspiracy theories.
Like what kind of theories?
Oh, everything from underground facilities built by advanced technology to it being a hidden Nazi stronghold where high-ranking officials supposedly escaped after the war. The stories are wild.
It's a story ripe for speculation, given the historical context and the place. If one were to investigate these claims today, decades later, what kind of evidence would you even look for? Maps? Diaries?
To conduct a credible investigation, you'd need to delve deep into historical archives, looking for detailed ship logs, original maps from the expedition, maybe diaries of crew members if any exist, or perhaps even aerial reconnaissance photographs from that era, though that's less likely.
And on the ground?
On the ground, scientists might employ geophysical surveys, things like ground-penetrating radar to look for anomalies beneath the ice or snow. Or literally search for physical remnants like building foundations, artifacts, unusual ice formations that might indicate past construction.
But the environment itself.
Exactly. The harsh Antarctic environment presents this dual challenge. It can rapidly bury or destroy evidence through massive blizzards and shifting ice,
Making things disappear.
But, paradoxically, it can also incredibly preserve certain materials like metal, well-sealed structures, even organic matter, for decades, even centuries, in its frozen, dry grip.
So maybe evidence is still there, just hidden.
It's possible. But one crucial consideration here, and it's really important, we must always maintain a critical balance between historical curiosity and the risk of falling into unfounded speculation, especially when dealing with such sparse and intriguing historical records.
Particularly when politically charged narratives get involved.
Precisely. Our goal here is to impartially report on the content that claims the expedition itself, not to endorse the conspiracies, but to understand the forces that create such persistent mysteries and why they capture the imagination. #, the dynamic Southern Ocean.
Shifting our focus now, let's look at the powerful forces surrounding Antarctica. We arrive at the Southern Ocean.
A critical component.
This vast, turbulent body of water encircling the continent adds its own layers of mystery. It has these powerful winds driving some of the strongest currents on Earth. It really acts like the planet's circulatory system, doesn't it?
It absolutely does. And the truly intriguing aspect here, and frankly alarming, is the fact of its rapid warming.
How rapid?
Some projections suggest potential warming rates up to 7 times current levels by 2100.
7 times? That's startling.
It is, and there's significant scientific uncertainty around precisely why it heats so quickly, why it absorbs such a disproportionate amount of the excess heat in the global system. It's a major focus for climate scientists.
Why is it so complex?
The dynamics involve deep ocean currents bringing warmer water up, atmospheric changes, the melting of vast ice sheets changing salinity. It's all interconnected in incredibly complex ways we're still working hard to fully understand.
7 times current rates. That's an alarming figure. So what could this accelerated warming mean for global ecosystems? For things like krill?
Krill, yes, the cornerstone.
Yeah. That tiny crustacean that's a keystone species for so many Antarctic animals. What about sea level rise? Global carbon cycles?
Putting this into context, the consequences are profound and incredibly far-reaching. Warmer waters, for one, reduce the ocean's ability to absorb carbon dioxide from the atmosphere,
Creating a feedback loop.
a dangerous feedback loop that accelerates global warming. It also severely impacts the delicate marine food web, particularly those krill populations.
Which feed everything else.
Krill are absolutely foundational to the Antarctic ecosystem. They provide food for whales, seals, penguins, fish. Their decline could ripple catastrophically through the entire food chain.
And the ice sheets.
Furthermore, this warming directly threatens the stability of the Antarctic ice sheets from below, contributing significantly to global sea level rise. And one crucial consideration emerges here:
What's that?
the weakening of the Antarctic bottom water.
Okay. What is that?
It's a very cold, very dense current formed in this region, primarily near the coast. It sinks and flows northward along the ocean floor, and it's a critical component of global ocean circulation, driving heat distribution around the planet.
And it's weakening.
Its formation appears to be slowing down due to the influx of fresh meltwater, which is less dense. Its disruption would undoubtedly affect climate patterns worldwide, potentially altering heat distribution and weather systems far, far away from Antarctica. This vital ocean is a global climate engine, and it's under serious threat.
Another oceanic enigma that really captures the imagination are these massive polynyas.
Ah, yes, the holes in the ice.
These enormous open water holes that inexplicably appear and persist within the vast, solid sea ice sheet. Like the one that surprised scientists when it just opened up in the Weddell Sea in 2017.
After decades of being absent, yeah, it was huge.
Okay, so what causes these?
The truly intriguing aspect here is understanding what forces prevent this water from freezing in sub-zero conditions, creating these inexplicable open areas. Is it intense cyclones tearing through the ice? Is it powerful ocean currents bringing warmer, deep water up to the surface? Or could it even be hidden geothermal activity from beneath the seafloor in some areas?
Multiple possibilities.
Yes, and their unusual persistence, sometimes lasting through entire winters, is an ongoing area of intense scientific inquiry. They aren't just simple holes, they're dynamic, complex features.
It's truly like a hole punched clean through the ice, seemingly defying the physics of freezing. How might studying these polynyas help us? Maybe predict changes in global ocean circulation or ice stability?
They offer a crucial window. Putting this into context, polynyas act as important areas for intense heat and moisture exchange between the ocean and the atmosphere.
Like breathing holes.
Exactly, like massive breathing holes for the ocean in winter. They significantly influence regional climate and sea ice formation around them.
And the Weddell Sea one reappearing?
The reappearance of the Weddell Sea polynya, after decades, really highlighted the challenges of predicting these dynamic events and modeling such complex systems. Studying them helps us refine climate models and understand critical feedback loops in the climate system.
And they connect back to that bottom water.
Very much so. They shed light on the planet's interconnected systems, particularly the formation of that Antarctic bottom water we just discussed.
Wow.
A lot of that dense water formation happens within polynyas during winter, as freezing sea ice rejects salt, making the remaining water super salty and dense enough to sink. So any changes to polynya activity, their size, frequency, location, could have significant implications for this vital global current, impacting ocean heat distribution and marine ecosystems worldwide. These dynamic windows are crucial to understanding our planet's complex climate engine. #V. Antarctica's deep past and otherworldly speculations.
Our deep dive takes us back in time now, way back, far into Antarctica's ancient past. And this truly sparks the imagination and challenges our present-day perceptions.
The really deep history.
We're talking about the astonishing discovery of fossils. Fossils of temperate rainforests dating back millions of years.
It's hard to fathom, isn't it?
Incredible evidence suggesting the continent was once lush and warm, teeming with diverse life, including dinosaurs like the imposing Cryolophosaurus.
The science behind this profound transformation is truly fascinating. How could such a dramatic shift from a verdant, temperate rainforest to the icy wasteland we know today, how could that possibly occur?
What's the story?
It's a story of immense geological and climatic change over vast timescales. The transformation is primarily attributed to plate tectonics,
The continent moving.
slowly but relentlessly moving the landmass of Antarctica to its current isolated position over the South Pole.
Okay.
Concurrently, there was significant global cooling, particularly during the Eocene-Oligocene transition around 34 million years ago.
Right.
This cooling, combined with the formation of the Antarctic circumpolar
The
current.
current isolating the continent.
Exactly. A powerful ocean current circling Antarctica, which effectively isolated it from warmer ocean waters from the north. This combination led to the rapid growth of vast ice sheets. It's a powerful illustration of Earth's dynamic geological history.
It's almost impossible to reconcile that image of a lush, ancient rainforest with the frozen landscape we see today. And of course, these kinds of discoveries, they always spark more than just scientific theories, don't they?
Well, absolutely.
Could these fossils hint at lost ecosystems we haven't even imagined, or even fuel more imaginative theories, ancient civilizations perhaps, even a mythical Atlantis hidden beneath the ice?
Well, it's certainly tempting to delve into such captivating theories. The idea of lost, advanced civilizations has a strong, persistent appeal in popular culture.
It does.
But it's really important to distinguish between the solid scientific evidence and speculation. For now, the overwhelming geological and climatic evidence points to a natural, albeit incredibly dramatic, geological and climatic transformation, not necessarily lost cities.
Understood. Science first.
However, putting this into context, reflecting on Antarctica's ancient past can profoundly inform our understanding of Earth's future under climate change.
How so?
Could the continent's history of extreme transformation, from rainforest to ice sheet, hold crucial lessons or even warnings for humanity as we face unprecedented global warming today? It shows us just how dramatically our planet can change and potentially how quickly over geological timescales. It truly is a continent of profound transformation, a powerful lesson for our future.
From the very real, yet almost unbelievable ancient past, let's explore the equally fascinating realm of speculation surrounding Antarctica today.
Ah, the weird stuff.
We're talking about unexplained sightings and anomalies. Persistent reports of unidentified flying objects, UFOs, darting lights seen by pilots or station crew, satellite anomalies that some interpret as crash sites,
Right.
or even geological formations that look strikingly like pyramids or staircases found in satellite imagery. These reports persistently weave their way through Antarctic lore.
The truly intriguing aspect here from a scientific perspective is to consider the range of rational explanations that could account for these sightings before jumping to extraordinary conclusions.
Okay, what could explain them?
What natural phenomena could mimic these reports in such an extreme environment? Well, unique ice formations, for one. Glacial carving and wind erosion can create incredibly deceptive shapes, especially when viewed from a distance or through atmospheric distortions.
Pareidolia, seeing patterns.
Exactly. Our brain's tendency to see faces or familiar shapes in random patterns, pareidolia plays a big role. Also, abandoned research stations, old equipment caches, even natural rock outcrops could easily be mistaken for anomalous structures, especially if partly buried by snow.
And the atmosphere itself.
Absolutely. Mirages are common in the polar atmosphere, caused by sharp temperature inversions. These can severely distort perceptions, making distant objects appear much larger, closer, higher up, or completely different shapes than they really are. Fata Morgana is a famous example.
So a lot of it could just be the extreme environment playing tricks on our eyes and minds.
It's highly likely for many reports. But okay, let's play devil's advocate for a moment. If we were to seriously consider something truly unknown or otherworldly, what would really constitute credible, undeniable evidence of extraterrestrial activity?
What's the benchmark?
To be truly credible, evidence would need to be irrefutable, independently verifiable by multiple sources and methods, and absolutely unable to be explained by any known natural or human-made phenomenon. No ambiguity.
Like what? A piece of tech?
That would likely involve physical artifacts that defy any terrestrial origin materials, construction, isotopes, unlike anything from Earth. Or maybe consistent, repeated, and decipherable signals that are clearly artificial and demonstrably of non-terrestrial intelligence, something truly unambiguous.
It's a high bar.
A very high bar. And one crucial consideration emerges. How would you even design a robust scientific investigation to definitively distinguish between optical illusions, human relics, natural geological formations, and something truly unknown or otherworldly?
How would you do that?
It would require a highly controlled, multidisciplinary approach, using advanced sensing technologies, radar, LiDAR, high-res imaging, spectroscopy, and rigorous scientific methodology to meticulously rule out all known variables first. You have to eliminate the mundane before claiming the extraordinary.
Makes sense.
Ultimately, Antarctica, with its extreme isolation, its vast unexplored areas, and its harsh alien conditions, it inspires such profound and often fantastic theories precisely because it remains so largely unexplored and alien to us. It's a frontier of the known and the unknown, a perfect canvas for human imagination. #6, the global barometer and scientific frontier.
As we approach the end of our deep dive, it's crucial we reiterate Antarctica's profound, undeniable role. It's the planet's regulator, its thermostat, its global barometer.
Absolutely central to the Earth system.
Its ice covers a staggering 98% of the continent. It holds about 60% of the world's fresh water, and the ice sheets are up to 4 kilometers thick in places.
It's an incomprehensible amount of frozen water.
Yes.
Just staggering.
The science behind its stability and vulnerability is truly fascinating, isn't it? Why does this immense ice sheet, which seems so stable, so immovable, why is it simultaneously so vulnerable to melting and collapse?
It's all about balance. A delicate and complex interplay between snowfall accumulation, which adds mass to the ice sheet, and ice loss through various mechanisms. There's calving, where massive chunks of ice break off the edges into the ocean, forming icebergs.
Output.
And then there's direct melting, both from warming air on the surface and, critically, from warming ocean currents eating away at it from below, especially where the ice floats or meets the sea.
And that balance is shifting.
This balance is incredibly fragile and increasingly under threat due to climate change. The output is starting to significantly outpace the input in many areas.
And speaking of vulnerability, let's talk about the Thwaites Glacier. It's got that chilling nickname, the Doomsday Glacier.
It's a very worrying place.
Why is this particular glacier considered so unstable? And how do these warm ocean currents undermine it from below, pushing it towards a potential catastrophic collapse?
Thwaites is critically unstable primarily because a significant portion of its base rests on bedrock that is below sea level. And worse, that bedrock slopes downward inland.
So as it melts back, the ocean can get further underneath.
Precisely. This makes it highly susceptible to relatively warm ocean currents water, known as circumpolar deep water, that can flow underneath the floating ice shelf at its front, eroding the grounding line, the point where the glacier loses contact with the bedrock and starts to float.
And that erosion weakens it.
It weakens the glacier, causing it to retreat rapidly, potentially leading to a runaway collapse as more and more of its base becomes exposed to that warm water.
And the consequences if it does collapse. Especially for coastal cities, we hear potential sea level rises measured in meters.
The collapse would be globally catastrophic. If Thwaites and its neighboring Pine Island Glacier were to entirely melt or collapse into the ocean, they alone could directly contribute several meters to global sea level rise over time.
Meters, not centimeters.
Meters. This would inundate countless coastal cities, displace hundreds of millions of people worldwide, redraw coastlines. It's one of the biggest potential tipping points in the climate system.
And putting this into context, Antarctica plays this vital role in global climate regulation just by being white, right?
Yes, the albedo effect.
Yeah.
Its vast, brilliant white ice sheets reflect a tremendous amount of incoming sunlight back into space.
Like a giant mirror.
Exactly. Think of it like a giant planetary mirror, crucial for regulating Earth's temperature and preventing it from overheating. It reflects far more solar energy than dark ocean water or land would.
But one crucial consideration emerges here. How does melting ice reduce this reflectivity, creating that dangerous positive feedback loop?
As ice melts, it exposes darker surfaces, either the underlying land or the dark ocean water. These darker surfaces absorb much more solar radiation instead of reflecting it.
So they heat up more.
They heat up more, which causes more melting, which exposes more dark surfaces, which leads to more heating. It's a classic positive feedback loop. It amplifies the initial warming, leading to accelerated ice loss across the entire continent, and further disrupting the global energy balance. It's a critical mechanism we need to understand and, frankly, fear.
Beyond the ice itself, Antarctica hosts this wealth of life in extremes. Organisms adapted to conditions that would instantly kill most other things on Earth.
Truly remarkable adaptations.
Take the emperor penguins, for example. Iconic. They dive to astonishing depths, maybe 500 meters down,
Incredible pressure.
surviving immense pressures and brutal cold that would crush and freeze most creatures. How do their physiological adaptations enable such incredible feats?
Their adaptations are truly remarkable. They have incredibly thick blubber for insulation, specialized feathers that create a waterproof, windproof barrier, and a unique countercurrent heat exchange system in their flippers and legs that minimizes heat loss to the icy water or ice surface.
Internally, too.
Physiologically, yes. Their blood contains a very high concentration of hemoglobin, allowing it to store more oxygen for long dives. They can dramatically reduce their heart rate and shunt blood flow away from non-essential organs during dives, saving oxygen and allowing them to remain submerged for extended periods, sometimes over 20 minutes. The bones are also denser than other birds, which helps them overcome buoyancy and dive deep.
Their resilience. It offers profound lessons, doesn't it, about survival in extreme environments, maybe even informing human endurance in challenging conditions.
Absolutely. And then there's the microbial life we touched on earlier. In the subglacial lakes, in the dry valleys,
Right.
psychrophiles that love the cold, halophiles that love salt, anaerobes that don't need oxygen, they thrive in conditions mimicking extraterrestrial environments.
How do they adapt? Using chemosynthesis, unique enzymes.
Yes, things like specialized enzymes that can function efficiently at sub-zero temperatures, unique cell membranes that remain fluid in the cold, mechanisms to cope with high pressure or high salinity. They teach us about the absolute limits of life as we know it.
But putting this into context, the implications for astrobiology are profound. Could similar organisms exist on Mars, Europa, Enceladus?
That's the tantalizing possibility. Finding life thriving in these Antarctic extremes significantly broadens the parameter space for where we might look for life beyond Earth. Antarctica is truly a natural laboratory of extreme adaptation, pushing the very definition of life.
It's truly inspiring to learn about these organisms, but all this unique biodiversity must be incredibly fragile.
It is very much so.
What are the key conservation concerns we should be aware of for this unique continent?
Putting this into context, warming waters and ocean acidification caused by the ocean absorbing excess CO2 pose significant threats to these unique species and their habitats.
Especially krill.
Krill, as we discussed, are fundamental. Their decline due to warming temperatures affecting the sea ice they depend on, plus increased fishing pressure in some areas. It would ripple devastatingly through the entire food web, affecting penguins, seals, whales, everything.
And habitat loss.
Habitat loss from melting sea ice is also a major concern, particularly impacting breeding grounds for penguins and seals that rely on stable ice platforms. This really highlights the critical importance of preserving this fragile ecosystem through strong international cooperation, like the Antarctic Treaty, and strict conservation measures. We need to ensure this incredible biodiversity can continue to thrive.
And that leads us perfectly to Antarctica's unique status as a scientific haven. It's a marvel of international cooperation, isn't it?
It really is. A beacon of hope in many ways.
The Antarctic Treaty of 1959, it bans military activity, prohibits nuclear testing, promotes unrestricted scientific research. 54 nations have agreed to keep this land neutral and demilitarized. Why? Why might nations, often in geopolitical competition elsewhere, agree to such a cooperative model for this one continent?
The science behind this cooperative model is truly profound, especially considering it was forged during the Cold War.
Right in the thick of it.
Nations recognize the continent's immense scientific value and the unprecedented opportunity for peaceful research. They understood, perhaps implicitly, that the benefits of shared scientific discovery, understanding climate, geology, the cosmos, far outweighed any potential nationalistic claims or resource exploitation, at least at that time.
So it's a global scientific commons.
Exactly. The treaty ensures Antarctica remains a global scientific commons, a shared resource for all humanity, dedicated solely to peace and scientific advancement. It's quite remarkable it is held for so long.
But this brings up a vital point. The challenges. What immense logistical challenges do scientists face conducting research there? Temperatures plummeting to -60°C, blizzards raging for days, months of darkness.
The challenges are extreme. Getting there, building and maintaining stations, operating equipment in the intense cold, the isolation, the psychological toll. It requires incredible planning, resources, and resilience.
So what motivates them? Why endure such extreme conditions?
I think it's the thrill of discovery, the chance to answer fundamental questions about our planet, its history, its future, the nature of life, the universe itself. Their discoveries on climate, biology, geology, astronomy benefit all of humanity. It's a powerful motivator.
And it's not just Earth science. Antarctica serves this unique, maybe unexpected role as a cosmic observatory, too.
That's absolutely right. It's incredibly clear, dry, stable atmosphere, particularly on the high polar plateau, offers some of the best viewing conditions on Earth for certain types of astronomy.
Better than mountaintops elsewhere?
For certain wavelengths, yes. It's ideal for telescopes studying the cosmic microwave background radiation, for instance, the afterglow of the Big Bang. And the thin, stable atmosphere is perfect for detecting elusive cosmic rays and neutrinos.
Neutrinos, those ghost particles.
Exactly. Particles that travel vast distances through the universe, barely interacting with anything. Experiments like the Ice Cube Neutrino Observatory.
Buried in the ice.
Yes. It uses a cubic kilometer of the deep, clear Antarctic ice itself as a massive detector, instrumented with thousands of sensors. It helps us deepen our understanding of the universe by tracing these high-energy particles back to their powerful cosmic origins, like exploding stars or supermassive black holes.
Using the ice itself as the telescope?
In a way, yes. And putting this into context, Antarctica also acts as a natural conveyor belt and collection point for meteorites.
How does that work?
The constantly flowing ice sheets gather meteorites that fall over a vast area and transport them towards the edges of the continent or towards mountain ranges where the ice flow stalls. Here, wind erosion exposes the dark meteorites against the white ice or blue ice fields, creating concentrated stranding zones.
So they just pile up?
Effectively, yes. Thousands of ancient meteorites have been found this way, some originating from Mars or the Moon.
Wow. Pieces of Mars and the Moon just sitting on the ice.
Exactly. Study of these extraterrestrial rocks, often preserved in pristine condition by the cold and dry environment, can reveal invaluable information about the solar system's early history, the formation of planets, maybe even the delivery of organic compounds relevant to the origins of life.
The thrill of finding a piece of another world in that frozen wilderness must be unparalleled.
Imagine, it offers a direct window into the cosmos, right here on Earth. Antarctica is truly a global scientific commons, revealing secrets not just of our planet, but of the entire universe. Hashtag outro.
What an incredible journey we've just taken together. A truly deep dive into the heart of Antarctica's enigmas.
We covered a lot of ground, didn't we? Or ice, rather.
We really did. We explored the astounding natural phenomena bloodfalls, that haunting symphony of singing ice. We journeyed across the Mars-like McMurdo Dry Valleys to the fiery heart of Mount Erebus.
And the human stories, too.
We delved into those compelling human stories, the lost explorers preserved in time, the psychological mystery of the third man factor, and even confronted the unsettling historical secrecy surrounding that 1938 Nazi expedition.
And we didn't stop there. We navigated the dynamic, rapidly warming Southern Ocean, pondered the mystery of those polynyas, those holes in the sea ice.
Right. We peered into Antarctica's ancient past, imagining those temperate rainforests teeming with dinosaurs.
Amazing to think about.
And considered the intriguing realm of unexplained sightings and otherworldly speculations that the continent seems to attract.
This deep dive has truly underscored, I think, that Antarctica is not just some static frozen landmass at the bottom of the world.
No, definitely not.
It is a living, breathing, and profoundly influential part of our planet. It acts as a critical global barometer for climate change, and it stands as a scientific frontier continually pushing the boundaries of human knowledge and our understanding of life itself.
Its complexity, its profound, stark beauty, and its crucial role in Earth's systems. It's all just undeniable. We sincerely hope this deep dive encourages you, our listener, to continue your own exploration
Yeah, keep digging.
into this endlessly fascinating continent. Maybe pick up a book, watch a documentary, just stay curious about what we've discussed today.
Absolutely, there's always more to learn.
Exactly. So, for you, our listener, here's a thought to mull over, something to carry with you beyond this conversation.
Okay.
Considering Antarctica's ancient past as a lush green continent, its present as a critical climate regulator facing unprecedented change, and its potential for revealing new forms of life or even cosmic secrets that could redefine our place in the universe. What ultimate, perhaps unexpected future secret does Antarctica still hold for humanity? And what profound responsibility do we bear in its unfolding story?
That is a profound question indeed. One that ties all these different threads, all these enigmas, together into a powerful call for stewardship, for respect, and for continued curiosity.
This has been The Deep Dive. Thank you for joining us on this journey into the unknown.